Welcome to the deep dive. Today we're peeling back the layers on something you definitely see all the time in big movies, big games. Motion capture technology.
Mocap, yeah.
Mocap, exactly. We found this great article that breaks it down, what it is, how it works, and maybe most interestingly, where it's headed.
Right. So think of this as getting you up to speed on how those digital characters move so darn realistically. We'll cover the basics, the process itself, which can get kind of complex. Look at some big examples you'll know. Talk costs, which can be pretty steep, and then peek at the future. AI and all that.
Sounds good. Let's jump right in. So fundamentally, what is motion capture?
Okay, simply. It's tech that records how something moves in the real world. Usually people, actors, but, could be animals too.
Okay.
And it turns that movement into digital data. That data then drives the animation for characters. So instead of animator drawing it all or keyframing everything by hand,
Right.
they're using a live performance as a foundation.
Ah, so you're getting the actual performance, the little details, the actor's specific way of moving.
Exactly. All that nuance. And yeah, the term is motion capture, or mocap for short.
Yeah.
Now, the article makes a good point. There's not just one way to do this. There are different flavors.
Okay, interesting. What are the main types then?
Well, the classic one, the one you probably picture, is optical mocap. That's where you have multiple cameras set up around a space.
Right.
And they track these little reflective markers on an actor's suit. Very precise.
Yeah.
But you need that controlled studio environment.
Yeah, I've seen pictures. Actors in black suits covered in little white dots.
That's the one. Then you've got inertial mocap. This is different. It uses sensors, IMUs, inertial measurement units.
Okay.
The actor wears these directly on their body. They track things like rotation and acceleration. Big plus here. Portability. You don't strictly need all those cameras or a dedicated studio.
Oh, wow. So you could potentially do it like anywhere. That seems useful.
Definitely opens up possibilities. And the third one mentioned, which really feels like where things are going, markerless mocap.
Markerless. So no suit, no sensors.
Exactly.
How does that work? Just magic.
Feels like it sometimes. It often uses really smart software and increasingly AI just analyzing regular video footage.
Just video.
Yeah. The AI identifies body parts, joints, and figures out their movement in 3D space without needing those physical tracking points. Pretty wild.
That is wild. Okay, so we've got the actor, maybe in a suit, maybe not. They do their performance. How does that turn into, Kratos smashing something on screen?
Right. So the process has a few key stages. First, like you said, the actor performs in the capture space or wearing the sensors. That gets recorded.
Got it. Action.
Right. That recording creates raw data, a lot of data points showing where those markers or sensors were at every moment.
Which isn't immediately useful for animation, I guess, just dots moving around.
Pretty much. That raw data needs processing. It gets converted into usable digital motion data. This is where the computer understands the 3D movement, the rotations, all that.
Okay, so now it's digital movement, but it needs a character to move.
Exactly. That processed motion data gets applied to what's called a skeleton rig.
A digital skeleton.
Yeah, think of it like the invisible bones inside the 3D character model. It's built to match the character's shape. The captured motion drives the matching bones in this rig.
Okay, makes sense. The digital puppet gets the real actor's moves. But scenes are complex, right? It's not just the character moving. There's the environment, cameras.
Good point. Yeah, putting it all together is the next big step. The article talks about using a timeline for each scene.
Like in video editing?
Kind of, yeah, but maybe more complex. You're synchronizing everything on this timeline. The character's motion, yeah, but also the virtual camera movements, the digital set, any visual effects, sound cues.
Wow. So it's coordinating all these different layers.
Exactly. It's fascinating how these separate pieces, maybe made by different people, all have to sync up perfectly to make the scene work, to feel believable.
It's way more than just recording the actor then. You're building the whole digital reality around them.
Totally. And this integration, this assembly, often happens in powerful game engines like Unreal Engine or Unity.
Ah, right. Used for games, but more and more for films too.
Absolutely. For virtual production, real-time rendering, all that good stuff. The article calls this whole process cinematic sequencing, basically, directing the final digital shot with all the elements locked together.
Okay, this is great background. Let's talk examples. Where have we seen this tech really shine? The article mentions some blockbusters.
Oh, yeah, big ones. Avatar, obviously.
Yeah.
Huge use of mocap, especially groundbreaking facial capture for the time.
Getting those Navi expressions right.
Exactly, making them feel real emotionally. And yeah, the article mentions the budget over $350 million. Gives you an idea of the investment.
Yikes. That's a lot. What about games? You mentioned Kratos.
Absolutely. God of War. The way Kratos moves, fights, climbs, it feels so physical, so weighty. That all comes from actors' performances captured with mocap.
You can really feel it when you play.
Totally. And The Last of Us, often held up for its realism, right? The article credits that tight integration of mocap performance with the world and the sound design. Makes the characters feel incredibly grounded.
Those performances felt so raw, so human.
He really did. And then there's something like Call of Duty. All those intense cinematic combat moments. According to the source, heavily reliant on mocap to capture that specific kind of authentic, high-energy military movement.
Right. It's not just fantasy creatures, it's realistic human action, too.
Exactly. And that's what's really interesting here, realizing this tech is fundamental now. It's not just for niche effects. It's core to how they achieve the realism we expect in top-tier entertainment.
Clearly vital for the big players. But it sounds expensive. Setting up those studios, the tech, what does the article say about the actual cost?
Yeah, it's definitely not cheap, especially at the high end. Those professional optical systems like Vicon, the gold standard, the article says they start around $100,000.
Wowzers. And that's just the system, right? Not the space, the computers, the operator.
Exactly. That's a serious barrier to entry. But the good news is there are more accessible options now, especially the inertial systems we talked about.
The suit-based ones.
Yeah. Companies like Rococo or XNs. Their systems, the article says, are more in the range of, say, $2,000 up to maybe $15,000.
Okay, that's a huge difference. Still an investment, but much more achievable for smaller studios or indie creators, maybe?
Definitely puts it within reach for more people. And then there's renting. You can rent time in a professional mocap studio.
Ah, like renting a soundstage.
Kind of, yeah. Fully equipped, calibrated space, often with technicians. The article estimates maybe $5,000 to $20,000 per day. Depends on what you need, obviously.
Still significant. It does make you wonder, with those costs, especially the $100 K-plus systems, does it create a bit of a divide, between the huge studios and everyone else?
That's a really important question it raises, yeah. Does cost limit who can access this level of realism? Seems likely, at least historically.
Okay. To really get a handle on this, the article breaks down some key terms. Bit of jargon, maybe?
Yeah, but useful jargon. Helps understand the workflow. So first, marker. We mentioned these, the reflective dots or the active sensors the system tracks.
Got it. The things on the suit.
Exactly. Then the skeleton rig, that digital bone structure inside the 3D character.
The puppet's bones.
You got it. Next up, retargeting. This one's crucial. It's how you take the motion captured from, say, a 6-foot actor and apply it convincingly to a 7-foot-tall alien character, or maybe a smaller character, adjusting for different body proportions.
Ah, so the movement looks right even if the bodies are different sizes. Okay.
Precisely. Then cleanup. Raw mocap data isn't always perfect. You get glitches, maybe a marker gets hidden for a second.
Jittery movements.
Yeah, or slight imperfections. Cleanup is the process of refining that data, smoothing things out, fixing errors, making it look polished, like post-production for the motion itself.
Makes sense. Polishing the performance.
Exactly. And finally, real-time mocap. This is pretty cool. It's capturing the motion and seeing it applied to the 3D character live instantly in the engine.
Whoa. So the director can see the digital character performing as the actor performs?
Yep. Great for immediate feedback, trying things out, even live digital performances.
Yeah.
So yeah, understanding these terms, marker, rig, retargeting, cleanup, real time, really helps picture the whole pipeline.
Definitely helps connect the dots. So we've covered the what, the how, the who uses it, the cost. Where does the article see this all going? Is the future just better versions of the same thing?
Well, the article's pretty clear. Mocap is the future of character animation, and the big catalyst, AI, artificial intelligence.
Okay, how is AI changing mocap?
The main thing highlighted is AI's impact on markerless mocap. Remember that?
Yeah.
Capturing movement without suits or sensors.
From video, yeah.
AI is getting seriously good at that. Analyzing standard video and extracting full body movement, even really detailed facial expressions.
Wow. That feels like it could completely change the accessibility, right? If you just need a good camera and smart software.
That's exactly the implication. It lowers the barrier massively. The article mentions tools like MetaHuman and Realusion as part of this wave, using advanced tech, including AI, to get amazing realism faster and potentially much cheaper than traditional high-end setups.
So the big picture here, it sounds like the tech is becoming more powerful and easier to use, maybe more democratic.
That seems to be the direction, yeah. Powerful tools potentially getting into the hands of way more creators, not just the giant studios.
This has been a great deep dive. We've really unpacked what motion capture is, the definition, the different kinds, how scenes get built, seen those big examples, wrestled with the costs.
And looked at where it's heading, especially with AI making things like markerless capture a reality. It's a technology that's still evolving really quickly.
It really is. Which leaves us with a final thought, maybe. Thinking about AI getting so good at capturing performance just from plain video, how could that change things? Who gets to create incredibly realistic digital characters and stories in the near future? Does it blow the doors open for indie creators, for artists who never could have afforded a mocap stage before? What kind of news stories might they tell? Definitely something to think about.